Hey, this video is about PCV, positive crankcase ventilation. So, it's the topic that over the past 10 years or so, I just see beat to death, and everyone thinks they have some new crazy way to do it. And everyone Googles a bunch of pictures or asks a bunch of questions and then takes ideas they like from everyone and puts together some crazy system. And you got cans and breathers and check valves and lines and fittings and weld on stuff and all kinds of shit. All right. And yeah. So I don't care what setup you use. I have my reasons for liking an open system on my turbo car. That's what I've ran for the past 10 years. That's what I'm going to keep doing. But you can run whatever you want if you don't like the smell or whatever. This is meant to be more informative about how the system actually works, because every other post I read someone talking about this, they're just completely not understanding it or regurgitating something they heard from somewhere else that was wrong, and no one actually looked at it. So, got bored today and decided to cut open the tube in my driver's side valve cover and pull out the positive crankcase ventilation valve. Now this is a regulator valve. It's not a check valve. So hopefully this will focus, but the way it works is there's just a plunger. So I have the plunger in my hand, and when this plunger gets pulled by vacuum, it seals. All right, so it's conical, so it's narrow at the top. So as you can see, there's a big gap. And then when vacuum pulls this out, which all the way up, it seals. Now it's extremely easy to pull out. I have the Ford service manual open. Ford didn't give me a rating on this valve, so I did my best to try to look up the system. They do have a schematic of this little regulator valve. And everything I could find online was that at 2 inches of vacuum it shuts. So it's designed to control the flow of positive crankcase pressure and oil vapors and acids and stuff that gets blown through your piston rings during combustion. And when there's enough pressure on this side in the manifold and not too much vacuum, it'll vent. What do I mean by too much vacuum? So at idle and decel and cruise and shit, this is pulled all the way out. I wish I had my little... I have a little trigger pull gauge that I tried to use. I used to measure trigger pulls on rifles and pistols and stuff, but I tried to get it in through that hole I cut in the side, and it wasn't working. I was getting hung up, and I don't want to mess it up, and I don't want to fully cut this open because I still wanted to show y'all how it worked. But so I'm not 100% on that, but from what I researched on this type of valve, and it was like on Mazdas and stuff, that at 2 inches of vacuum and greater, right, so this plunger side goes this way, which goes to the tube that goes to the intake manifold, and it's on the engine side of the throttle body. So that's where there's vacuum all the time under idle, cruise, and decel. So what that tells me, with how I get one of these in your hands, it's literally takes nothing to pull that plunger all the way out. So vacuum is pulled on this, which is sealed in there, and it stays shut. So what does that tell me? This side only vents at high RPM, high load, wide open throttle type situations. So when throttle's close to fully open, or when you get less than 2 inches of vacuum in the intake manifold, this valve will crack open. Now it might happen sooner. So if you have some blow by and you have a little bit of pressure, a pound of pressure is about 2 inches of vacuum. So if you had a pound of pressure in the crankcase, and when you come off throttle, theoretically it'll open around 4 inches or something like that, because you have a pound pushing here and vacuum on that side. But anyway, you get the idea. So the biggest thing about that is it's a regulation valve. Like I said, above 2 inches of vacuum, that valve is shut. This plunger pulls out, and there's no vacuum being pulled on the crankcase. I see guys talking about, yeah, you need vacuum on the crankcase. No, it wasn't designed that way. This valve allows pressure to vent and protects the crankcase from excessive vacuum. It's designed to shut when vacuum is high to keep that from happening. And you could figure out many reasons. My take on it is tighter tolerance motor, high pressure, high volume oil pump. You got all these extra oil passages, and then the phaser solenoids, and the heads needing oil, and got to get oil all over the place. You got windage. These cars had factory windage trays, which limits pressure generate, because some crankcase pressure gets generated just by the crank spinning. So the windage tray keeps oil in the pan and also stops windage in there. Factory car with a windage tray. That had never happened before the '05 Mustang. So anyway, when guys think they're leaving a side shut and they're adding check valves and they don't do anything about this, like, oh, I need a lot of vacuum to seat my rings. Like, it's not a thing. I don't know how to explain that any better, that it's not a thing. It doesn't make any sense to me that on a modern motor and the volume in the crank, the tolerances on the rings and all that, like, it's not. Computer aided design, everything's tighter, smaller, lighter. It's not a loose tolerance, big displacement, big cavity motor where if you don't put a vacuum pump, either belt driven or electric, in your 400 plus cubic inch motor, yeah, you're gonna have ring issues and oiling issues and stuff. That's not the case on these cars. I put breathers on my car a couple months after I got it, even when it was still in A. Before, because I had plans to turbo it and I just hadn't at the time. But I went ahead and put breathers on it and got rid of all that stupid emissions shit. So, and I never had an issue with it in A. I never did anything with the tune. Everyone says it messes up the tune. Whatever. Yeah, alright. So, the stock system. So, like I said, I have the Ford manual open here. And here you can, if you go open the Ford manual, it talks about how the PCV system works and how it vents air and regulates the vacuum. Alright, and you got yourself a diagram here. And it looks a little weird, but we're looking at the back of the engine. Well, we would be looking at the back for the Mustang. So, driver's side, passenger side, if we're looking from the back. So that's where that little regulator PCV valve is. This goes to the intake manifold. There is your throttle body, your mass airflow sensor, your air box, and then you have a line coming to the passenger side tube. There's no valve. That side's open. That side, as you can see, fresh air. So fresh air, when pressure is generated and the conditions are there for it to open, it opens. That vacuum pulls everything out and sucks in fresh air as it's doing it. And that's what happens as you transition from wide open throttle to cruise and so forth, and create the vacuum pressure differential situation where that little plunger can open and release anything and allow air to get sucked in. And that's the stock system. Alright, so now let's boost it. Alright, what's the problem with that? Most guys are like, oh, I don't want to boost my freaking manifold. I would agree. You don't want to do that. Some people will put a check valve. Some people want to keep it closed. Easy way is you just put a breather and then you're fine. So, but if you want to keep it closed, people will put a check valve, which will protect you from pressure. But now let's think about how we just looked at that valve, right? So when vac gets above about 2 inches, that valve is shut. So nothing is happening here. So you just have vacuum pulling on this and it stays shut. As you transition below 2 into 0, when you're wide up throwing in a car, you get some flow and you get some ventilation, positive ventilation. But now I'm boosting my motor at wide open throttle. This has nowhere to go. So if I look at this valve, it's going to push. Sorry, let me set this up so y'all can see. So that's going to be fully retracted. The pressure here is going to keep that pushed in. It's going to push around it. And there is a valve seat in the bottom, but it doesn't appear to be a perfect seal. So around that little valve, it's going to be really hard for you to see. You might be able to, if I can get this angle just right, there's a little notch. So this valve isn't a perfect circle. There's like little notches around the outside for flow. And just looking at it when I hold it all the way flush, it doesn't look like a perfect seat. So I would agree, add a check valve, because I don't think that little plunger valve, is a regulation valve. It's not a true check valve. It's not designed to prevent flow in one direction. So absolutely cool, add a check valve. That protects the motor. So when you're forcing air through here with your power adder and you have pressure, that protects that pressure from forcing its way through that little regulator valve and then pressurizing your crankcase outside of blow by in the piston rings and the cylinders, which is normal. But like I said, like I'm getting to now, we looked at that. Is that setup acting as a way to relieve pressure? So we just talked about when I'm boosting, and I put the check valve there, I just have pressure sitting here. There ain't shit coming out this side. There's nowhere for it to go. There's pressure on the check valve, or pressure sitting on here, bleeding into the here. Nothing's coming out. All right, now let's transition back to vacuum. So we let go, blow-off valve, bypass valve. This goes back to vac. You get some suction on this. You get that very brief second coming off boost where this opens for a little bit. Now on an NA car, that's fine. That's all you need, and that works. But if you're putting depending on your tolerances, your ring gaps, how much boost you're running, the health of your piston ring setup, that's not adequate. I can guarantee you that's not adequate to vent. Especially if you have this side closed still. Right? Because this side, and I've even seen people like, oh no, it creates suck. There's vacuum here and air gets pulled out here. Like, no, that's not how it works. Vacuum only exists on this side, right? And then like, oh well, shit. I need to move this to the inlet of my turbo or supercharger, so I'm not boosting it. Cool, got it. And it creates suction, so I'm sucking air in. I'm like, no, it's not how it works. You do have a little bit of suction, but not enough on this small line to create any kind of vacuum or any kind of pull. This line is meant to pull fresh air in. Or if you run a breather, just pop a breather on there and it vents. Or like I've seen people run like a hybrid where a couple supercharger manufacturers who didn't fucking pay any attention, just like, oh, just leave this side closed and leave this side open. Because it worked and they were able to tune a car and it was fine. Great. This side alone is often not enough to vent your crankcase under pressure, even at 10 pounds. It's a much smaller tube on that side compared to the tube on this side. And that's why often guys are blowing out dipsticks, blowing out oil pan gaskets, timing cover gaskets, you name it. Yeah, so people add the oil neck breather. That helps a lot. That usually solves most people's problems. So then you can leave the system intact, although it's not doing anything. You might as well just like cap that or close it. Because on a boosted car, leaving that valve, adding a check valve, leaving this connected, you're not venting anything back in. It just doesn't work right. That small transition period coming off boost straight into vacuum, it's being, the check valve. You probably have locked. I mean, even if you add a check valve, there's probably just locked vacuum in here, and that valve just stays shut. And then when you transition back to vacuum in this vents, it also stays shut. So you don't have a split second when that's opening on a boosted car. Not enough to do anything. Not enough to get rid of what's needed to be getting rid of on a boosted car vices in any setup. So again, it all ends up coming out that side, which again is also usually not big enough. So add that oil neck breather, or what I've seen guys do before, I've just never had the need to do it or wanted to pull my valve cover off to do it, is pull that out. And then that's a much bigger way to vent your setup. Now, if you want to run that to a catch can with a breather, I would. I just would not. Even if you remove this, once you're boosted, this line going to the manifold here is null and void. So if I were to pull that, add a check valve, okay, cool, I'm keeping pressure out. But then when you transition to vacuum, you're getting fucking full vacuum force in here. You don't want that. The OEM system is designed to not have a ton of vacuum in there. This regulator prevents that. And we just looked at how it operates. When vacuum is higher than about 2 inches, this valve is pulled shut. If Ford wanted a ton of vacuum in the crankcase, there wouldn't be a valve that prevents it. Plain and simple. I don't know how else to look at that or how to explain that to anyone differently. But yeah, okay, like, I want to pull that, so then I can get full vacuum. Now you're just going to jack shit up. You're going to pull a shit ton of air in through here. More so, like, if you leave it, that little bit of pull here, when everyone talks about unmetered air, because you often go to blow through. So when you move the MAF to the other side of your power adder, this air, and this tube is still connected to intake side of your power adder, that little bit of air that does little bit that does pull through here, and that small time window when we talked about when that's open, it's not significant, and everyone's seen that. They're like, oh, unmetered air, you're gonna run lean, but most guys won't have it zero problem, because again, this isn't doing shit. So you're pulling almost no air in here. It's not noticeable. It doesn't affect your tune, because this doesn't fucking work anymore. When you're blown, when there's pressure in here, this setup just completely doesn't work right. So, you could vent it, like we talked about. But like I said, if you're trying to keep it closed for any reason, there's just no point. You have a higher risk of that check valve failing. And like I said, this thing's a little dinky piece of shit. I wouldn't want to be, especially if you're running 15, you got a built motor, you're running 15, 20, 25 pounds of boost. I wouldn't want to be pushing pressure past this thing, hoping that seats in the bottom, and then unnecessarily hurting your motor. So I just don't see, from a basic fundamental of how the system appears to work, based on what I can physically see and looking at Ford's diagram, I don't know why people decide to keep that side shut still. After looking at this, my best recommendation would be to remove that valve, the PCV valve, and run this to a vented catch can somewhere. If you don't like the smell, run a line to under the body of the car, down the fuel line, back by the exhaust, where you have gas and oil smell already. And, if it comes into the cabin or something. Or run it down into the bumper, or however guys like to do it. Something like that. But I just can't recommend leaving that side closed and opening that side. And again, that's why people talk about all open, all closed. All open, breathers everywhere, good to go, simple. It just doesn't make sense. So take away from this what you will. Again, you can go forward and find this diagram of the OEM setup. Take a look at this shit for yourself. Figure out what you want to do for your car. But yeah, if you've had issues with popping out dipsticks and stuff, your setup's probably not right. Yeah, I think that's it. All right, it's kind of long, but I think there was one more thing I wanted to talk about. Nope, don't remember. All right, so use this what you will. Have fun. I'm not trying to start a flame war, but if you have questions, I can try to answer them with my personal experience from working with these setups and running different setups and seeing different setups and working on friends' cars, customers' cars, all kinds of shit. I've seen a lot of different setups, and like I had an understanding, like my viewpoint on all of this didn't drastically change, but after actually seeing this little regulator valve and doing a little research, yeah, it just re-emphasized everything I had kind of learned through the grapevine and learned on my own of running stuff. And hopefully someone finds this helpful. All right, that's it.